So now this is part 2 of the video. Till now we've done the truncated end view and the truncated plan. Now we're gonna do the development. We start as per normal. You draw a horizontal line. Personally, I try to make it the biggest possible that I can so I know for sure that I have enough space. Now, compass, take one side of the plan and create 6 spaces. Why 6? Because it's a hexagon. So 1, 2, 3, 4, 5, 6. Number them. 1, 2, 3, 4, 5, 6, and with 1 again. Okay, so for now, extend a vertical line from all points. Same thing as with the horizontal line, I try to make them longer than I need them to be. So I know for sure that I have enough space. Now for point 1, I'm gonna go on one of the front view and open till the cuts. Open till my second point number 1, really, like that, and place them here. Go on point number 2 and also 6. Open till the cuts. Plot points 2 and 6. For 3 and 5, open. Now it's going to be the full length. Full length. And it's also going to be the same as 4. So we can plot 3, 4, and 5 with the same compass measurement. And join them all together. Don't forget to make them bold. And don't forget to draw the folding lines. So folding lines, 1 big, 2 small, 1 big. 1 big, 2 small, 1 big. Whoa. One big, 2 small, 1 big. 1 big, 2 small, 1 big. 1 big, 2 small, 1 big. And 1 big, 2 small, 1 big. Okay, so there you have the development. Okay, now true shape of cut, the last step. So we're gonna go to the plan and we're gonna find the center. In this case we already know our center, and we're gonna draw a line like this. 1 big, 1 small, 1 big, and we're gonna call this line x1, x1. Okay, now I'm gonna set my set square parallel to the cuts. Okay, why? Because I'm gonna draw 90-degree lines from each point of the cut that I have. Okay, now I'm gonna set my set square again to the cut, and here calculate approximately half of the plan and make it a little bigger. Make the space a little bigger. You can take an approximation. That's what I do, okay? And draw a line like this. 1 big, 1 small, 1 big, and call it x and x. So this line XX is equivalent to x1, x1, okay? When I mean equivalent, we're going to consider them to be the same line, okay? Now, as you can see, the cut does not lie on points 3 and 5. It lies on a point here, slightly next to it, okay? So we're gonna see where that leads on the plan. On the plan, it's over here. I have 1 point over here. Can you see 5 is over here? And the cut line is over here. You wanna... Oh. So I'm gonna just call the cuts on the plan point A and point B. Shh. That's just Toby. That's just a dog. Now, to plot point 1 is directly on line x1. Look, can you see? Point 1 is exactly on x1. Now I'm going to see where point 1 is here. So the line of point 1 is this line over here. Now, since I know point 1 lies directly on the line x1 and x1, I'm going to plot it here on xx. Because as we said, line x1 is equivalent to xx. Now, we're going to see for point 2 and 6. 2 and 6 are over here. So I'm going to put my compass here, okay? And open till either point 6 or point 2. They're going to be the same, okay? They're the same. Go here on the line that is dedicated to points 2 and 6. And draw an arc here. And an arc here, okay? And here I have 2 and 6. Now, why did I create A and B? Because this line is not dedicated to 3 and 5, because it does not lie on line 3 and 5. It's dedicated to A and B, because those are the cuts, A and B. Okay, so when the line does not directly lie on a number, the cut does not directly lie on a number, you have to create 2 new points, okay? I prefer, instead of calling them 7 and 8, to show that they're different, I call them A and B. A and B, so now I go back on the plan, place my compass on X for A and B, and they're the same length as 6 and 2. So I place my compass here, on the line that is dedicated to A and B on the X line, and draw the 2 arcs, A and B. And I join the lines together with my set square or with any other ruler, it's fine. Okay, and there I have the true shape of cut. And that's it. That's it.